Assalamu alaikum. Today I will talk about my project three-phase YY connection. My name is Abdullah Alkaf from RK23 Group 1. So I will start with the introduction. Three-phase transmission are more economical for supplying large loads and large power distribution. Even though most of the initialization equipment it is connected by the single phase transmission. To increase or decrease the voltage in the three-phase system, three-phase transmission are used. Three, there is more than one way to conduct three-phase transmission, and one of them is YY way, and it is our way to conduct in this project. Our objective. We have three objectives. Uh, First one, to evaluate the parameter of the electrical system and conducts of transmission and load impedance, currents, voltage, and unacceptable voltage drop beside on the PS 7671 standard or any Malaysian standard. To hence the initialization system in our daily life to evaluate and analyze the active power absorbed by loads, justify the normal operating condition of the electrical system, and relate the study with the simulation. Our methodology in this project. In this project, we first found the value of the voltage line and the value transmission loss and the value of the load beside on the instruction given. We did the design of the three-phase YY circuit. In this project we use two ways to find the value of total power. First way is a conventional measuring method, and the second one is the wattmeter method. By using the given value of the voltage line, the value transmission loss, the value of the load, we will find the currents. For simulation part, we design a three-phase circuit by using PSM program to build the report result with the simulation. And for the result and discussion, I will explain by the report for more details. So open the report. First, our B line is 275 kilovolt, and our load is 71 plus 9 I ohm, and transmission loss is 78 ohm. It is all given in the question. Because our phase is positive sequence, so VAB it will be equal 275 kilo with 0 angle, and BBC it will be equal also 275 kilo with minus 120 angle, and VBA and VCA it will be equal 275 kilo with 120 angle. And to find the phase voltage, B line leads B phase by 30 degree. B phase we can find B phase by this formula: B line over the square root of 3 with angle 30. So we will get 15877 1.3 with angle minus 30 volt. So Vn it will be equal also 15877 1.3 with minus angle 30 volt. VBN it will be equal 15877.3 with minus 150 angle, and VCN it will be equal 15877.3 with 90 angle. To find the line currents, we will use this formula, and we got the value of 1063.6 with angle minus 33.5. And to find the IPP, we will use the same formula, and we will get the same magnitude but different angle. The angle it will be minus 153.5, and the ICC it will be equal same the magnitude, but the angle it will be 86.5. Because IL equal I load equal I phase, so it will IA equal be IN, and IBB equal be IBN, and ICC it will be equal ICN. To find V phase load, we will use this formula. V phase load equal V load over square root of 3, and we will get 1.15877.3 volt. To find the active power absorbed by the loads by using 2 wattmeter method, this is the result of first wattmeter, and this is the result of the second wattmeters, and the total power it will be P1 plus P2, and it equal 502.5945 kilowatts. And the second way is to find the power using this formula. V load equal 3 multiply with V phase load multiply with I phase load multiply with cosine theta, and we get this answer 502,590.5.14 kilowatt. Same answer. We get the same answer from the two ways. Also we get the power factor by this formula, and the answer it is 0.992. Also we get the result of transmission line loss by this formula. The answer it 8237.107 kilowatt, and voltage drop we got it from this formula by using this formula. V supply minus V load over V supply multiply with 100%, and we get 5.2%, and we get 52%. So that's about the calculation. Discussion. In this project we work by BS7671 standard. So beside on this standard, the voltage drop doesn't exceed a percentage of 5%. In my case, the voltage drop is 52%, and that is not the average percent of the voltage drop according to this standard. So it is not the normal steady state operating condition. For the power absorbed by the load, we use two ways to find the value of total power: the conventional measuring method and the wattmeter method. For the power factor, according to the electrical supply application handbook by TMP, it is stated that the voltage is less than 132 kV. The power factor needs to be minimum 0.85, and for 132 kilovolt and above, it is need to be minimum of 0.9. In this project, the voltage is 275 kilovolt, so the power factor needs to be minimum of 0.9, and in this report we got 0.992. About the simulation, so we'll see our simulation, and this our design for the circuit, and this is the our this for currents and this for voltage. Conclusion, in the end we found the value of the line voltage and line currents, phase current, and value of total power by two ways. The result was the same value, that was 502,590.5945 kW. As we found the power factor value, that was 0.992. Also we calculate the voltage drop and we got this value. It is 52%, and it was not the average percent voltage drop according to our standard. To get the average percent for voltage drop, we should make a change in the YY circuit. Okay, thank you. That's it. Thank you.